Well, hello everyone, and welcome back to the Mr. Moffat Show. This is the first video in a series of videos that's going to teach you about chemical reactions and equations. I've already filmed this video once, and it was 18 minutes long, so I decided to film it again and cut it short. So this is going to be a no-nonsense, bare-bones video. Any explanations that are required by you should email me, and I'll be glad to elaborate some more in a different video or something. All right. So what the heck is a chemical reaction? Well, a chemical reaction is something you studied before. You've probably known it as a chemical change. Yes, those terms are synonymous. You've probably had other definitions for chemical reactions or chemical changes, but this one here, in my opinion, is the best. A chemical reaction is something that happens. What happens in a chemical reaction? Well, one or more substances will transform into one or more other substances by breaking and or forming chemical bonds. That's right. The forming and or breaking of chemical bonds is essential in order to call something a chemical reaction. For example, you might say that when ice, one substance, melts, it turns into liquid water, another substance. Well, that's not entirely true. Both ice and water are actually the same substance, they're just in different phases. One's a solid and one's a liquid. Furthermore, when ice melts into liquid water, there's no forming or breaking of any chemical bonds. The formula for water is the same whether it is a solid or a liquid. So that is not a chemical reaction. A chemical reaction involves breaking and forming of chemical bonds. Also, very important to know is that when a chemical reaction occurs, the new substances that are formed by it are very different from the original substances that went into the chemical reaction. Primarily, they're different by their formulas. And also, they differ by their properties, and those properties are sometimes drastically different. Here's an example of what I'm talking about. Forget the sandwich analogy. We don't have time for that. Okay? Let's take our good friends iron and rust. Iron is a nice metal. It's very dense. It conducts electricity, and it's very good building material. You can use it to build or create things such as cast iron pots and pans. Now let's take our other good friend, oxygen. Oxygen is an invisible gas. It's essential for combustion. You learned that when you were a kid, that things will only burn in the presence of oxygen. And it's also essential for your life. You have to breathe oxygen day in and day out all the time, or else you die. Okay? Well, iron and oxygen can undergo a chemical reaction. And when they undergo a chemical reaction, they form or turn into something called iron 3 oxide, which is better known as rust. So what is rust? Rust is a flaky, brown, crusty material that's easy to crumble. It cannot conduct electricity like iron. You can't really build anything out of it like iron, and it certainly does not have iron's high density. Rust is partly made of iron, yet has none of its properties. Rust also is not an invisible gas. You cannot use it to support combustion, and you can't breathe it and live. Those are all properties of oxygen. They're not properties of rust. Rust might contain oxygen, but it has none of its properties. So here is a third new wonderful substance caused by the chemical reaction between these two substances. The formula for rust is Fe2O3. That is a different formula from Fe, and it's different from O2. Furthermore, as just illustrated, it has very different properties from either of those two substances. Even though rust contains them, it does not have their properties. It would be foolish to think that if you wanted to live, you could breathe rust. Well, rust contains oxygen, and you need oxygen. True, rust contains oxygen, but in a way it doesn't. All right, then. Oh, come on, I'm trying to flip the page. Here we go. So that's the nuts and bolts of chemical reactions. What then is a chemical equation? It is a written description of everything that happens, almost everything that happens in a chemical reaction. Because it is written, it has rules. Many of the things that we write have rules, such as letters. You have to write a letter A correctly. such as words, right? Words are spelled, have correct spellings. Even sentences have correct structure so that you can communicate clearly. There are rules that dictate all of these things. So there are rules that dictate how chemical equations are written. Excuse me. All right then. So let's take a look at chemical equations. A very basic or simple chemical equation is what we call a word equation. And a word equation uses words to describe everything involved in the chemical reaction. For example, this is a word equation to describe the reaction described a few minutes to depict the reaction that I described a few minutes ago. Iron undergoing a reaction with oxygen, and they turn into iron 3 oxide, aka rust. So I've written the names of iron and oxygen on the left side of an arrow, and we have a special word for the things written over here, and that is they are called the reactants. That blue blob right there is supposed to be the letter C. I don't know what happened. Reactants. The reactants are the materials that begin or go into a chemical reaction. They're the ones that undergo a transformation and turn into something else. The iron and the oxygen are the elements, or in this case, or the substances rather, that either break or form chemical bonds so that they can transform into something else. Reactants are always written first, and they're put to the left side of an arrow. I'll explain more about the arrow later. A chemical reaction can have one reactant, or two, or a dozen. There's no limit or rule as to how many reactants there can be. On the right side of the arrow are the products or the leftover or the things that the chemical reaction produces. And because they are produced by the reaction, we call them products. That's right. In this reaction, iron 3 oxide is the only product. A chemical reaction can have just one product or it can have many. And products are always written on the right-hand side of the chemical reaction. I'm sorry, to the right-hand side of the arrow. Before a reaction begins, the product does not exist. For example, when you take iron and just plain old oxygen, there is no iron oxide. But when they undergo the chemical reaction, they start to form iron 3 oxide. And after the chemical reaction occurs, then iron 3 oxide does exist. All right, so there's two important vocab terms for you, reactants and products. Reactants are the starting materials, products are the ending materials. There can be multiple reactants or just one. There can be multiple products or just one. And reactants can be elements, such as in this reaction here, or they can be compounds. The same holds true for the products. The products can be any collection of elements and or compounds. There are two other important elements to a good word equation, all right? And one of them is that arrow right there. You might be tempted to think of that arrow as equals, right? Nope, that's not a really good way to conceive of that arrow because iron and oxygen most definitely do not equal iron 3 oxide. They're not equal. They have very different properties. So the best terms that that arrow could stand for are as follows. Let's see. Here's a good one. Produces. Produce or produces. Iron and oxygen produce iron 3 oxide. That's a good one. Yield or yields, which is fairly synonymous with produces. Or another good one is turns into or turn into. In my opinion, all three of these, and there's probably more, are good ways to think of what that arrow stands for. The other important symbol here, and this one tricks up a lot of people, is the plus sign. The plus sign can mean positive charge if you're looking at ions. It can also mean addition in a mathematical context. And it's very tempting to think of that plus sign to mean add or to combine or put together. But that's not the best thing that to think of when you look at the plus sign. When you see the plus sign in a chemical equation, in a word equation, the best word for it is simply and. That's right. The left side of the arrow is simply a list of the reactants, and the names of them are separated by the plus sign. It just means and. Now, you might argue that the plus sign could mean combine or put together. For example, in the word equation below, we're reacting magnesium and hydrochloric acid. The hydrochloric acid is a liquid. You have to put this liquid into a beaker and set it on a table. And then you have to take a piece of magnesium and add it to the hydrochloric acid. This is true. This is true. You are physically combining the magnesium and hydrochloric acid by putting them in the same container. So in that context, okay, there's an argument there that this plus sign can mean combine or add or put together. But what about this plus sign over here? Does that mean that the hydrogen and magnesium chloride, the two products, do they get added together? No, in fact, quite the opposite. In this example here, the magnesium chloride is a product that will stay in the beaker. It's a substance that stays dissolved in liquid. But the hydrogen is a gas, and it floats away. It flies up into the atmosphere, never to be seen again unless you put a container over it. So this plus sign cannot possibly mean add in this situation because the magnesium and chloride and the hydrogen do the exact opposite. They actually get separated from each other. So guess what? If you want the plus sign to mean add, then you should go across the hall into math class, okay? Because here in chemistry, in these equations, it really best stands for the word and. You'll get used to it. All right, we don't need these. All right, now a word equation is nice, but what we are going to write and work with in chemistry are what are called balanced chemical equations. And balanced chemical equations have two rules. One, they have to have the correct formulas for each reactant and product. So word equations are nice because they use names to describe the reactants and the products, but formulas are better. So in a balanced chemical equation, we'll write Fe for iron, we'll write O2 for oxygen, and then Fe2O3 for iron 3 oxide. The second rule, and this one is equally important, is they have to be balanced, which is why I call them balanced chemical equations. Balanced means that the chemical equation obeys the law of conservation of matter. You've learned the law of conservation of matter, and if I asked you what it was, you would probably say something like, in chemical reactions, matter is neither created nor destroyed. And that's a great description of the law of conservation of matter. But it's important for us to look at it in a slightly different way or rephrase it, and that is to say that during a chemical reaction, the mass of the products is equal to the mass of the reactants. That's right. So if materials undergo a chemical reaction, if you weigh them before they react and then weigh them after they reacted and turned into products, the mass of the reactants and the mass of the products should be equal to each other. This is one of the key core fundamental principles behind all of chemistry. So a good written chemical equation will adhere to it. Okay. So what does it mean to be balanced? Well, I'm actually going to save that for the next video. In the next video, I'm going to teach you more about what it means for a chemical equation to be balanced, how they are written so that they are balanced, and then I'm going to teach you how to balance them. That is all for now. I hope you all have a great day. And have a nice day.